Welcome to the DIY Honda Garage channel. The DTC code P2245 indicates a low voltage condition on the VCENT circuit of the AF sensor, specifically Sensor 1, which is a critical component of the engine's fuel mixture regulation system. The air-fuel AF sensor plays a vital role in measuring the amount of oxygen in the exhaust gases, allowing the engine control module, ECM, to adjust the fuel ratio for optimal combustion. Sensor 1 is typically located in the exhaust stream prior to the catalytic converter, where it can effectively monitor the exhaust gases. Given its importance, any issues indicated by this DTC can affect engine performance, fuel efficiency, and emissions compliance. A diligent troubleshooting process is essential to ensure that connectivity, performance, and integrity of the AF sensor and its related circuits are maintained. The DTC P2245 indicates a malfunction related to the AF sensor, specifically the VCENT circuit. The AF sensor collects data on the air-fuel mixture and communicates with the engine control module, ECM, to adjust fuel delivery, which is crucial for maintaining optimal engine performance. When this sensor indicates low voltage in the VCENT circuit, it may hinder the ECM's ability to properly adjust this mixture, which can lead to poor engine performance, increased emissions, and reduced fuel economy. The AF sensor is generally found in the exhaust manifold, and issues with this sensor can have a cascading effect on various engine functions, directly impacting drivability and efficiency. Several possible causes could lead to the triggering of DTC P2245. A short in the VCENT wire can occur due to wear and tear or improper routing of wiring, disrupting the voltage signals needed for proper sensor operation. Moreover, poor connections or loose terminals between the AF sensor and the powertrain control module, PCM, could impede electrical flow, leading to a voltage drop. An outright failure of the AF sensor itself is another common cause. Electrical components can wear out and lose functionality over time. Lastly, issues within the PCM itself, such as defects in its internal circuits, could also contribute to erroneous voltage readings and ultimately trigger this DTC. When the DTC P2245 is triggered, the most apparent symptom is the illumination of the check engine light on the dashboard. Drivers may also notice decreased fuel economy due to inefficient fuel mixture adjustments, which prevent the engine from operating at optimal efficiency. Additionally, performance issues may arise, such as rough idling, power loss, or hesitation when accelerating, as the engine struggles to maintain the correct air-fuel ratio for combustion. If left unresolved, these symptoms can lead to further degradation in vehicle performance and potentially more severe mechanical issues. The first step in troubleshooting DTC P2245 involves verifying the problem using the Honda Diagnostics System, HDS. Begin by turning the vehicle to the on mode, which powers the vehicle's electrical systems without starting the engine. Next, utilize the HDS to clear any existing DTCs. This step is crucial, as it resets the system and prepares it for a fresh analysis. After clearing the codes, start the engine and hold its speed at 3,000 RPM without any load until the radiator fan activates, signaling a state readiness for testing. This controlled environment helps to check if the DTC is still indicated. If so, it confirms that a persistent failure exists. Thus, you can proceed to the next steps with confidence. For the second troubleshooting step, ensure the vehicle is turned off and in lock mode to eliminate any electrical signals during testing. Utilize the HDS to jump the SCS, System Communication System, line, which allows for testing of the system without interference from other functions. After waiting for over a minute, disconnect both the PCM connector E 80P and the AF sensor, Sensor 1 6P connector. With the connectors disconnected, check for continuity between the PCM connector E number 74 and body ground. If a continuity exists, it indicates a short in the VCENT wire between the PCM and the AF sensor. Therefore, repairs should focus on resolving this short to restore proper communication and functionality of the sensor circuit. In the third step of the troubleshooting procedure, reconnect the previously disconnected PCM connector E 80P to re-establish communication with the module. Next, ensure you exit SCS mode using the HDS, making the PCM fully operational for voltage measurements. Turn the vehicle to on mode to activate the electrical systems required for this test. Measure the voltage at the AF sensor, Sensor 1 6P connector, specifically at female terminal number 4 against the body ground. If the voltage reads 0.2 volts or less, this suggests a potential fault in the PCM. Thus, further actions would involve consulting authorized service information or substituting a known good PCM to isolate the issue. If this results in the disappearance of DTC P2245, the original PCM should be replaced. After conducting the necessary repairs based on earlier steps, it is crucial to perform a final verification to ensure the issue surrounding DTC P2245 has been resolved. Start by confirming all connections are secure and components functional. Next, clear any DTCs using the HDS and conduct a test drive under various driving conditions to validate the repair. During the test drive, closely observe the vehicle's performance, especially the behavior of the engine and any warning lights on the dashboard. If the check engine light does not reoccur and engine performance remains stable, this indicates successful repair of the fault. This step solidifies confidence in the reliability of the repairs made. Preventive maintenance plays a crucial role in minimizing the risk of recurring DTC P2245. Regular inspections of electrical wiring and connections should be part of routine checkups. This includes looking for signs of wear, fraying, or corrosion that could impact performance. Additionally, ensuring the integrity of connectors, especially those tied to the AF sensor and PCM, will help prevent poor electrical contact issues. Monitoring the performance of the AF sensor is also essential. Early detection of unusual performance or sensor readings can help address potential faults before they escalate into larger problems. By implementing these preventive measures, you can contribute to the long-term health of the vehicle's engine management system. In conclusion, addressing DTC P2245 requires a thorough understanding of the AF sensor's role within the engine management system and the specific conditions that lead to its failure. Effective diagnostics are essential to pinpoint the issue, whether it's a short in the wiring, a faulty sensor, or a defective PCM. The integrity of electrical connectors significantly impacts sensor functionality. Ensuring their proper condition can prevent many issues from arising. Regular maintenance practices, including inspections and voltage testing, are crucial in extending the lifespan and reliability of the AF sensor system. Awareness and proactive management of these components will help ensure optimal vehicle performance and compliance with emission standards. Please like and subscribe to the channel. See you next time.